All right, let's dive right in. If you've ever been in a Java technical interview, you know there are a couple of questions that are pretty much guaranteed to pop up. We're talking, of course, about abstract classes and interfaces. So today, we're going to break them down. What are they? What's the difference? And maybe most importantly, why should you care? Okay, so the interview kicks off with a real classic. The interviewer asks, "Can you explain what an abstract class is in Java?" Let's see how the candidate tackles this one. The candidate nails it with a perfect analogy. An abstract class is like a blueprint. That's such a great way to think about it, and it's key to understanding everything else. So let's really dig into what that means. So here's the absolute number one rule you gotta remember. You can't make an object directly from an abstract class. You can't just say new abstract class. It won't work. And the blueprint analogy holds up perfectly here, right? You can't live in a piece of paper, the blueprint. You use that paper to build a real house you can live in. Same idea. And this is where their power really shines. It's this awesome mix and match capability. Think of it like a kit. It comes with some parts already built for you. Those are the concrete methods you can just use. But it also has these empty slots, these some assembly required spots. Those are the abstract methods, and any class that uses this blueprint has to fill in those blanks themselves. Okay, let's look at the code. It's actually pretty simple. See that word extends? That's the magic keyword. That's how you tell Java, hey, my car class is using the motor vehicle blueprint. It's inheriting all the pre-built stuff and promising to fill in all the required details. All right, so the interviewer pivots. We've talked about the blueprint. Now what about the other big concept, interfaces? And if an abstract class is that kind of flexible blueprint, then an interface, well, that's a whole different ballgame. It's way more like a legally binding contract, no wiggle room. And you can see the difference right away. An interface is a pure contract. It's just a list of promises. It basically says, look, I don't care how you do it, but if you sign this contract, you absolutely must provide these specific abilities. It gives you a to-do list, but zero instructions on how to do it. It's all on you. Yeah, it's all about defining a specific behavior. The candidate's example of a stack is perfect. The stack interface just promises you'll have methods like push and pop. It couldn't care less if you build your stack with an array, a linked list, or a pile of magic beans. As long as you fulfill the contract, you're good to go. And just like before, there's a keyword for this. For the blueprint, it was extends. For the contract, it's implements. When you see that word, you know the array stack class is signing on the dotted line. It's officially promising to follow every single rule in that stack contract. Okay, so we've got the blueprint and we've got the contract. Now for the million-dollar follow-up question you know is coming in the interview, what's the real difference? Let's put them head to head. This table really lays it all out, doesn't it? You see how the abstract class, the blueprint, can give you both finished methods and empty ones. The interface, on the other hand, is just the rules. But honestly, the biggest, most important difference for how you design your software is right there in the middle, inheritance. You can only inherit from one parent, one blueprint, but you can sign as many contracts, implement as many interfaces as you want. That's a huge deal. And this brings us to the real heart of the matter, the so what question. Why do we even have these things? Answering this well is what shows an interviewer you don't just memorize definitions. You actually understand software design. It all comes down to this one powerful idea. We want to write our code to depend on the abstractions, the blueprint or the contract, not on the nitty-gritty details of one specific class. If your code only knows it's dealing with a vehicle, it doesn't have to care if it's a car or a bike. This makes your whole system way more flexible. And that flexibility has a name, polymorphism. It sounds fancy, but it's really the superpower you unlock by using these tools. It simply means you can treat lots of different objects the same way, as long as they follow the same blueprint or contract. A bicycle is a vehicle, so you can just pop it into any piece of code that's expecting a vehicle. It just works. So what's the payoff? Well, here it is laid out in 3 steps. This isn't just theory for an exam. This is the practical, day-to-day recipe for building good software. Software that you can actually change and add to later without the whole thing collapsing like a house of cards. It's how you build things that last. So at the end of the day, what's the big takeaway? It's that abstract classes and interfaces aren't just some random syntax you need to memorize to pass an interview. No way. They're fundamental, powerful tools for designing software. And knowing when to reach for that flexible blueprint versus when you need to lay down the law with a strict contract, well, that's what really elevates you from just a coder to a true software architect.